Okay, so my advanced 8th grade math kids, I hope that yesterday was okay and you at least understood 80% of what I was teaching. 100% would be great, but this is just going to reinforce what we were talking about. So if you didn't get it completely, then this will be a refresher and just reinforcement. So on this one, we're going to be again writing expressions and finding patterns. They wanted us to break up into groups, so if you were in like a classroom setting, we'd be breaking up into groups. But we're not in a classroom setting, so we're just going to pick one. I'm going to pick pattern C to do. So they want us to draw the figure out, draw a few additional figures, and then organize the information to a table. So we have 1, 2, 3, so we'll put here figure 4, and we'll do figure 5. Okay, so all it is doing is it's adding 4 each time, right? So I'm having 4 added to each end of this figure. So this one had 1, 2, 3, so 3 on each leg. So we're going to do this 1, 2, 3, 1, 2, 3, 1, 3, and then we're going to add one more. So we got each leg is. Oh wait, I think I added too much on that one. So 1, 2, 3, 4. So this one is good. This one I think I added too much. Yeah, so that's good. All right, so now we're going to do the same thing here. So I'm going to just add one more. So this is 4, so we're going to do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's what our figure should look like. Now let's organize it into a table. So we got X and Y here. Okay, so our first one had 1, our second one had 5, our third one had 4 more than that, so that would be 9, and then our fourth one will have 4 more than that, that will be 13. 4 more than that will be 17. And 4 more than that will be 21. So we're just adding 4 each time. That's the pattern for this figure. So I need to figure out what my starting value is, so I can write my expression. So remember, if I add 4 to get the next one, I can subtract 4 to get the previous one. So if I want to get what the value is when x is 0, then I'm going to have to subtract 4. So 1 minus 4 would be -3. So when x is 0, y would be -3. So my starting value is -3. So I'm going to need that. That's going to be my constant. And I need to figure out what the constant difference was. My constant difference was 4. Okay, so we have our constant difference, we have our starting value. So now we can write an expression. So we're going to increase by 4 each time, so we're going to put 4 in. And then we're going to subtract 3 from that number. Okay, and you should have learned this, like I said, from the previous lesson, but this is just kind of a refresher. So anytime you have a constant difference, that's going to go in front of the variable, because that's what's changing each time. And then you got to add in what your starting value was. Okay, all right, so we're going to go to the next page. Describe the pattern in words, it says. We're going to say it increases by 4 each time. Write an expression using the variable n that could be used to determine the number of pebbles in figure n. That would be 4n minus 3. We had figured that out just on the previous page. Use your expression to determine the number of pebbles in the 10th, 53rd, and 200th figure. We didn't do A, D, or B, so we're just doing C. So we can write this expression out, or this rule out, right? We're going to put 4 times 10 minus 3. So the 10th figure should be 40 minus 3, which is going to be 37. The 53rd would be 4 times 53 minus 3. And let's see what that would be. 53 times 4 is going to be 12. And then 21. And then that minus 3. Right, it's 12. 21. And then minus 3. That's going to be 12 minus 3 is going to be 9. 209. And then here, the 200th figure minus 3, what would that be? So 200 times 4, it's going to be 800 minus 3, that'd be 297. I'm sorry, not 297, 797. 797. Okay, hopefully you can see that. I know it's kind of far. But if I zoom in, I'm afraid that it's going to get all blurry. This says, for the pattern you selected, is it possible to have a figure with 100 pebbles? Explain your reasoning. Well, if you notice, all of these are odd numbers, and that's because when you have multiples of 4, we're going to put multiples of 4 will always be even, and if you subtract 3 from an even number, that number will be odd. And 100 is not odd. It's not an odd number. So it can never be 100. Based on the class's work for item 1, how does the constant difference in a pebble pattern relate to the algebraic expression that can be written to describe the pattern? We're going to put the constant difference is the number we multiply to the variable number. Okay, sorry, so I'm just trying to get through this as quickly as I can because it's a lot. If you need to pause the video and kind of read over it a little bit more, then you can feel free to do that. So we're going to go to the next page. So on this one it says check your understanding. We got 2 patterns here, pattern A and pattern B. You want to find the constant difference of each in the tables. So my constant difference here is going to be 3 to 7 is going to be 4. And 7 to 11, that's also 4. This is 4, this is 4. Here we have, this is going to be 2 plus 5 is 7. 7 plus 5 is 12. So this is a constant difference of 5. So for pattern A, we have a constant difference of 4. And for pattern B is a constant difference of 5. For each pebble pattern, use the variable n to write an expression for the nth figure. So again, we have to figure out what the starting value is first. So if I go back 1, right, I'm just going back 1 because they started at 1. If they started at like 3 or 5, I would have to, maybe subtract 4 several times. But since we started at 1, I just got to go back 1 more. So I'm just going to subtract 4 once. So if I'm going back 1 step to get the starting value when x is 0, hold on, sorry, it's blurring. then 3 minus 4, that's going to give me negative 1. So that'll be my starting value for this one. Okay. So for A, my expression is going to be my constant difference of 4n, and then my starting value minus 1. So that's A, and then B is going to be, I have to go back, so I want to get the starting value. So at 0, if I subtract 5, from 2, that's going to give me negative 3. So my starting value for B is negative 3. So I'm going to have 5n minus 3 here. Okay, so it says how many pebbles are in the 50th figure for each pebble pattern. So we just need to put 50 in for the n on both of these. So 4 times 50 minus 1, that's going to be 200 minus 1, which would be 199. And that's for A. And for B, we're going to put in 50 here, minus 3. So 5 times 50, that's going to be 250 minus 3. So 250 minus 3 is going to be 247. Both pebble patterns have 7 pebbles. In figure 2, if the pattern continues, will they ever have the same number of pebbles as another figure? Explain your reasoning. I would say no, because if there's a constant difference, then these are represented by lines. So these are linear, and after they cross, they will never cross again. So what does that mean? What I'm saying is, if I were to graph these two expressions, or sorry, these two relationships on a graph, I would have one maybe going up like this, and maybe one going up like this, sort of like this. And that part where they intersect, right here, that was here. They both had the same value there. So that was their intersection, 2, 7. Okay, but if you look, two lines can only intersect once. They're not going to turn back around and intersect again. So once they intersect, they're only going to intersect one time. So they will not have the same value again. Okay, so let's go to the next one. The Pythagoreans also study the following pebble pattern. So we got this going on. How many pebbles are there in the 4th, 5th, and 6th figures? So if you notice, it's kind of making a square each time. So the 4th figure, it's going to have 4 sides. So this one, the sides are 3. This one, the sides were 2. This one, the sides was 1. So we're going to do one with 4. 1, 2, 3, 4. 1, 4. And just fill it in. So this was the 4th. The 5th would be same thing, but 5. So 1, 2, 3, 4, 5. 4, 5, fill it in. And then the 6th one, 6, right? So 1, 2, 3, 4, 5, 6. 1, 5, 6, and then fill it in. Okay, so that's the 6th one. Okay, so if you notice, we could count it out, right? We could count it out, but you know from area formula from before that the area of a square is just a side length times the side length. So if I wanted to know how many pebbles, I could just do 3 times 3 and know that this is 9, right? So let's check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 3 times 3 is 9. So that means for this one, if each side is 4, all I need to do is do 4 times 4 for the fourth one, so that would be 16. And then this one would be 5 times 5, that would be 25. This one, 6 times 6, that would be 36. Does this pattern have a constant difference? Explain your reasoning. Well, let's look. So from 1 to 2, I have a difference of 3, right? It increased by 3. On this one, this increased by 5. On this one, you increase by, 4, 5, 6, 4, 5, 6, 7, yeah, 7. So, as you can see, those are not constant. So it's not a constant difference. So we're going to say no. And explain your response. Subtracting I can't spell consecutive terms does not give the same number. Describe the pattern in words. It is a square that increases in length and height by 1 each time. How many pebbles are in the 10th figure? How do you determine your answer? Okay, so far the side length has been actually the same as the figure number. So we could just say the figure number, right, times itself. So that could also be written as n squared. So if I want to figure out what the 10th figure is, all I have to do is do 10 squared. That's going to give me 100. Okay, so let's go to the next one. It says, how many pebbles are there in the 40th figure and in the nth figure? So 40th, again, we do 40 squared, which is just 40 times 40, right? I just want you to know that that's the same. So 40 times 40, what would that be? So we got 0, 4, 0, 16. So that'll be 1,640, if I'm not mistaken. Oh wait, hold on. I am mistaken. Whoops. Hold on 1 second. Okay. This would just be 0. 4 times 0 is 0. 4 times 4 is 6. Sorry, it would be 1,600. That was a mess up on my part, sorry. So it would be 1,600. And the nth figure, like we said, is just going to be n squared. The Pythagoreans call the numbers in this pattern the square numbers. Why do you think this is so? Because they form squares. The numbers in the pebble pattern shown below are called the rectangular numbers. How many pebbles are in the 4th, 5th, and 6th figures? Okay, so so if you look at the area, right, if we're thinking area again, how many pebbles are in the 4th, 5th? Actually, let's just draw it out first. Okay, so if you notice, it's kind of like the square ones, but we're adding one more row. So it's the length is increasing by 1 more than the actual figure number, and then the width is the same as the figure number. So if this increases, if this is 4, then my next one is going to be 5 tall and 4 wide. So we're going to do 1, 2, 3, 4. Oh, I need to make this as big as that one because it'll look weird. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. And then just fill it in. So this is 4. This one is 5. This is 5. I'm going to do 6 on this one. And by 5, 1, 2, 5, fill it in. And then 6, same thing. So we'll do 1, 2, fill that in. Okay, so to get the area of this, let's say this number is n, right? So this is n. So this is always the actual n. Whatever the figure number is, that's what the width is. And this is n plus 1, right? This is just increased by 1. So for the fourth figure, I'm going to have my length would be 4, and my height would be 5, right? It would just be one more. So this would be 20 for the fourth figure. For the fifth figure, I'd have 5 for the width and 6 for my height. So that would give me 30. And then for my sixth figure, I'd have 6 for my length and I'd have 7 for my height. So that would give me 42. And if you want to actually count it out, you can actually count it out and verify that. So let's just look. So for the fourth one, it would be 20. So let's leave 1, 2, 3, 4, 8. 8 plus 8 is 16, 17, 18, 19, 20. So 20. So we know that's correct. Describe the pattern in words. Is there a constant difference? Explain your response. Well, let's see. So from 2 to 6, it's a difference of 4. Right? Yes. And then here, this is a difference of 6. Right? Because we added on this outside part, so that would be 3, 4, 5, 6. And then on this one, we added this outside part, that's 4, 5, 6, 7, 8. So it is not there's a pattern there, but it's not the same number. So there is not a constant difference. So no constant difference. Because consecutive terms subtracted do not have the same value. Describe how to find the number of pebbles in the 10th figure. So we just talked about this. So the base, or the length, would be equal to 10, and the height would be equal to 11. So 10 times 11 would give me 110. How many pebbles are in the 30th figure? So we would do 30 times 31, right? Just one more for the height. So that would give me 930. And for the nth figure, like we just talked about, it's just going to be n times n plus 1. So whatever the figure number is, times that figure number plus 1. Okay, The Pythagoreans called the numbers represented by the pebbles in this pebble pattern the triangular numbers. Why do you think the Pythagoreans called these numbers triangular? Well, they look like triangles, right? And the figures look like triangles. Okay, let's go to the next page. So it says, how is the triangular number pebble pattern related to the pebble pattern of the rectangular numbers? Well, let's look. So here are the rectangular numbers, and here are the triangular numbers. Do you think if I add this same thing here, what does that look like? If I add this same triangle on top of that one, doesn't that look like the rectangular one? It does, right? So let's put that down. We're going to put the triangular, oh sorry, need to write lower. The triangular numbers look like half of the rectangular numbers. So use your response to part B to write an algebraic expression for the number of pebbles in the nth triangular number. Well, wouldn't we just take the rectangular one, right? The n times n plus 1 and then divide it by 2? Yeah, we could do that. Verify your expression by substituting n equals 4 is the result of the number of pebbles, the fourth triangular number. So let's see. So if I put in 4 here, wherever the n is, will I get the same number of pebbles for the fourth triangular number? Let's see. So this would be 4 times 5 divided by 2. So that would be 20 divided by 2. That'll give me 10. So let's look at, let's go back to the next page, or the previous page. So if I was to extend this out, right, all you can see is that the slant is increasing by 1, and then they just fill in the edges. So if I make my slant be 4, and then I go down and fill this in, that's going to give me 4 plus 4, 5, 6, 7, 8, 9, 10. Yep, there's 10 here. So we're going to say yes. Use your expression to predict the number of pebbles in the 30th triangular number. Okay, simple. 30 times 30 plus 1 over 2. So we had actually already gotten this, right? 30, that was the one that we did here. Right, so that's 930. So 930 divided by 2. So if we divide this by 2, let's see, 930 divided by 2. 2 goes into 9 twice. No, sorry, 4 times, sorry. 4 times. That gives me 8. Then I got 13. That goes into it 6 times. Bring down 1. 2 goes into 2 goes into 10 5 times. So this would be 465. Okay. So I'm gonna, for time's sake, it's already at like about 30 minutes. I'm gonna let you do your check your understanding and then your practice. Just do the best that you can. Maybe Jury and Isaac, you can work together on this if Ms. Tessel allows that. Okay, thank you guys so much.